Good morning. Am I audible? Good morning, good morning, good morning. Am I audible? Okay. So dimension you completed, practice from some book or maybe you completed, but all problem right now you cannot do because all formula you don't know. But parallelly in whole year you have to do the dimension. You have to find the dimension of the different quantity what you are learning. Okay, and in the revision time I will discuss some problem that I will include all those formula. Okay, now I will discuss small topic today. The basic concept like significant figure, rounding off, all these. Okay, but before that, one small concept has given in NCERT. They never ask, but we are using in the telescope also, astronomical telescope. So parallax method. Okay, so in short, parallax method. What is a parallax method? Why we are using? Okay, so basic mathematics we already cover how to find the distance of the far object and all. So parallax method is what? One thing, it is used to find distance of the far object. It is used to find distance of the far object. Like suppose I am asking the distance of the moon, so from the earth, so we cannot measure from the scale, no? So for that what we are doing, we are using the parallax method. Okay, what is the meaning of parallax? So if anybody you went in the physics lab and you have done any optics experiment, so one optics experiment is there, finding the focal length of the convex lens by use convex lens displacement method, by the displacement method. Okay, how many of you went in physics lab? They have done some practical in physics lab. Anybody is there who done some practical optics practical in the physics lab? Because they introduced some practical also, like last year they introduced some practical. Okay, good. 2 member, 3 done, sir. 3 member, good. Okay, so if you have done that practical, very good. Okay, more members are there. So when you were doing the displacement method experiments, so one pin was there, like how the whole setup was what? There was a convex lens in between, one pin was there, pin was like an object, okay, and this side you are observing. So when you are observing from through the lens, so one position, the examiner who was the lab assistant or teacher, they were saying, when you will see the image like this, means like this through the lens you are getting this type of situation, then means it is a position of the image where the object and image we can say coincide, or it is a real position of the image. Okay, you are getting like this. Okay, but they were saying after seeing this you have to rotate your head, okay, when you are rotating your head and this is going together like this, okay, then it means it is a actual. Otherwise what will happen, from the front when you observe it will appear like this, but when you rotate your head they will get separate. Okay, what was the reason? This experiment you can do at home also. Suppose you mark one black dot on the wall. Suppose you mark one black dot on the wall and close your one eyes and take pen, pencil or any object, thin object, and put in the front of your eye and hide so that you will unable to see the dot. Like one eye you close, you put the pen or pencil in the front of you and make the dot in your front wall, black dot in the front wall. Adjust the pencil so that you cannot see the black dot. Okay, so you got the position of the pencil. But now when this eye open and this eye close, okay, then what you will see, you have to change the position of the pencil, then only you can hide the dot. Okay, what is the reason? Reason is what? Both eye are not coinciding. There is a distance between the eye. So whatever the position I'm getting the pencil for one eye, that will be not same for the other eye. Okay, so this is happening. Why? Because the distance of between the both what eye. Okay, so that is the parallax basically. So when they are saying rotate your head like this, so it means what? For both eye it has to coincide. Then it will be what? Actual position of the image. Are you getting what I'm saying? So this like that is called the parallax, and one thing has given distance between the both eyes called the basis. Okay, all these things has given in the NCERT. So parallax method is what I said. Parallax method is used to find the distance of the far object. Okay, what is a parallax that I said? Okay, like when we are using the one eye, then we are getting the object, but when we are using the another eye, then the position is changing. So distance between the eye we know, that is a basis. On that basis we can find, like suppose I am saying you have one far object. Okay, any far object is there, and that object diameter is making an angle or subtending an angle alpha at the any point O. Suppose observer is here and this object is far and it is making an angle, its diameter is making an angle alpha at the point O. Okay, so this alpha is called the parallax angle. This alpha is called the parallax angle. Same like in our eye this distance and it is making some angle at the dot. Okay, are you getting what I'm saying? Like eyes, the distance between the eye is this basis, and when you join with the black dot, you will get some what? One angle. That angle is the parallax angle. Same way here, this diameter is making the angle alpha at the O. Okay, this alpha is the parallax angle. Now, when the distance is large, then what will happen? Angle will be small. Like if I'm talking about the moon diameter is large. But moon is far from us. Moon is far from us, so it is making a small angle in our eye. It is making a small angle in our eye. When you are very close to the moon, it will subtend large angle. But when you are far, it is making a small angle in the eye. So when angle is small, then one thing I said in basic mathematics also, when angle is small, then straight line length we can take as an arc, or arc we can take as a straight line. Then we can say what? Angle is equal to arc upon radius. So arc what I will take? Capital D. Radius what I will take? Distance. By this angle we can find diameter of the moon. Suppose we know, then we can find the distance of the moon from the earth. Like this way we can find the distance of the far object from any point. So I repeat again, what is the parallax method? Parallax method is used to find the distance of far object, in that what we are doing, like from the observer at the observer, if the object is making a small angle alpha and the distance of the object from the observer is x and diameter of the object I took capital D, then what is the angle? I can say angle is equal to arc upon radius. What is the arc? Capital D. What is the radius? X. Okay, one thing why I am taking this as an arc. So moon diameter is very large. So maybe you're thinking, sir, moon diameter is very large, but you are taking the arc length is small, then straight length we can take as an arc. So here moon diameter is large, but in our eye it is what? It is making a small angle. And when you are taking you as a center and you draw the circle, you will get very big circle. So for that arc will be small. That's why moon diameter we are taking small. Everybody getting or not? So ultimately, when the object is far, we can use the formula angle is equal to arc by radius. That is straight length we can take as an arc. Then we will apply the formula. Okay, alpha is equal to d by x. X is the distance of the object from the observer. Capital D is the diameter and the alpha is the angle. And one more thing I said, wherever angle we are using, a unit not written means default unit of the angle is radian. So what is the unit of alpha? Alpha is the radian. Any problem anybody has, then you can ask. Okay. So why it is a parallax method? What is the meaning of parallax? Okay, why I said for the eye? Because for the eye, if we are taking the one eye, so image pencil or what I gave the example, means we have to change the position of the pencil. Why? Both eye are not coinciding. Okay. So that's why same way like here, our eye, it is making the angle alpha at the dot. This is the distance between the eye. So this alpha is called the parallax angle. Same way here also. This diameter, it is making angle alpha at the observer. So that's why this I am saying the parallax method. Okay. Okay. So and we'll use this formula in NCERT solved example 1 and 2 question has given on this formula, and later in the optical instrument telescope again we will use this. Okay. So small question we can do. If diameter of Earth then find distance between Moon and Earth. So what I said, if the diameter of the Earth 1,2800 kilometer, then it subtended an angle of 1 degree 30 minutes on the Moon, then we have to find the distance between Moon and Earth. So for this what I said, first thing, this we have done in basic mathematics, degree and minute, 30 minute. What I said, degree work as a hour, minute as a minute, second as a second. Means we know that 1 minute is equal to 1 by 60 hour, or we can say 1 minute is equal to 1 by 60 degree. So first what we will do, if they given the angle in minute and second, whole angle we will convert in degree. After converting in degree, then multiplication factor I said, when you multiply the angle in degree with pi by 180, then angle you will get in radian. After getting in radian, then we can apply the formula. Okay. So here first what we will do, we will find the angle in radian. But for that first we will convert the whole angle in degree. So theta, what I can say, 1 degree 30 minute. 30 minute I can say what, 30 minute is equal to how much hour? Then I can say 30 by 60. All we have done in basic mathematics, I think everybody know. That is equal to what? 1 by 2 degree. 1 by 2 degree, or you can say 0.5 degree. Okay. So 30 minute is the 0.5 degree. Then total degree, total angle what we have? Total angle I can say theta is equal to 1.5 degree. Or I can say what? 1.5 into pi by 180, then you will get in radian. So means pi by 120 you are getting. Like this is a 3 by 2. 3 and this you will cancel, so 60, and by 2 means you will get the pi by 120 radian. Okay, after getting the angle, then I can use the formula angle is equal to arc upon radius. Then pi by 120 angle is equal to arc, what I will take, diameter. Diameter is what? 12800 kilometer upon radius means what? Distance. Now you can find the x value. Once again, what I said here, this whole we have discussed in basic mathematics, means how to convert the degree into radian, radian into degree. One thing I said, if you have to convert the degree into radian, any angle they given in degree and you want to convert into the radian. So multiplication factor is what? Pi by 180. When angle in the degree you are multiplying with pi by 180, then you will get the angle in radian. Okay. Angle they have given in degree, you want in radian, so multiply that factor with pi by 180, then you will get in radian. If suppose they given in radian and you want to convert in degree, then multiplication factor is a reverse, 180 by pi. So when you have the angle in the radian and you want degree, then you will multiply that angle with 180 by pi. Okay, so only the two factor pi and 180. One case we are multiplying pi by 180, one case we are multiplying 180 by pi. Okay, here I gave the angle is what, 1 degree 30 minute. So minute and second are the small unit of the angle. Okay, so 1 degree, that is a degree that we know. Okay, here I gave the 30 minute. 30 minute means 60 minute is equal to 1 hour. 1 hour means 1 degree. 1 hour means 1 degree, we can say. So 60 minute is equal to 1 degree. 1 minute is equal to 1 by 60 degree. So 30 minute unitary I am using. 30 minute is equal to 30 by 60, that is equal to 0.5 degree. So now total angle what we have, 1 degree what I gave, and 30 minute is equal to 0.5 degree. So total degree what we got, 1.5 degree or 3 by 2 degree. Now you got the angle in degree, convert in radian by multiplying pi by 180. Okay, understood or not? Who asked this, sir, once again? Okay, after that we will apply the formula, angle is equal to arc upon radius. Okay, so x now, after that you will calculate 12800 into 120 by pi. For closer answer you can take the, you can check pi as a 3 and then multiply. Approximately 4.8 into 10 to the power 5 kilometer will come. Okay, because in these cases they will not give very close option because they know that calculation is a lengthy. So pi you can take as a 3 and check the option. Okay, closer answer you can go, and slightly lesser you have to check because pi you are taking 3, but basically it is a 3.14. So whatever answer you are getting, slightly less than that you have to check. Okay, completed. Okay, now next very small concept. Rounding off. All this you have learned. Rounding off you have learned in that which class? Rounding off in which class you learned? Who will say? Rounding off. So in the class 4th, I think 4th and 5th, we have learned the rounding off. Okay. So most of you know the concept of the round off means what we are doing. Okay. In the form of example, I will explain. I'm not going to write all the rules. Okay. So example, one example, and I will explain the rule. Okay. So what is the meaning of rounding off? Sometime like whatever the answer we are getting in the calculation, whatever answer you are getting, like you are getting the decimal 3 places, but we have to write the decimal 1 place only, or we are getting decimal 2 place, but we have to give the answer in the decimal 1 place. Means last digit, 1 digit we have to remove. Okay, then we are using the concept of the round off. Okay, in the significant figure it is required. When we will deal with the significant figure, then rounding off is required. Even in error also, sometimes we will write the error with the proper significant figure, then there also it is required. Okay, so what is a rounding off? Rounding off means when we are removing some digit, like we required lesser number, but in our data more digits are there. So if you want to remove some digit, you have to follow the round off rule. Okay, so what is the rule? Suppose I'm writing the example, with that I will explain. Suppose here I gave the one number 3.42. 3.42. You have to round off up to the 1 decimal place. Okay, means after the decimal we have to write only 1 digit. So I have given the 2 digit after the decimal, that is a 3.42. So which digit you have to drop? Which digit you have to drop? So you have to drop 2. You have to drop 2. Okay. the digit which you have to drop, if it is a, there is a rule, if it is a more than 5, if it is a more than 5, then preceding digit will increase by 1. Now maybe you will recall what you learned. If the digit which you have to drop, if it is a more than 5, then preceding will increase by 1. If the digit which you have to drop is less than 5, then preceding will remain unchanged or will remain same. Okay, that is the first I am saying for the greater than 5 and less than 5. So here 3.42 I gave. I have to write the decimal one place, so means I have to drop 2. I have to drop 2, and 2 is lesser than 5. 2 is lesser than 5. Then directly we can draw what I said, greater than 5, then preceding increase by 1. Less than 5, then preceding will remain unchanged. So then what I can write, 3.4. Okay. Now maybe everybody recall the rule. Now suppose I am saying 2.48. 2.48, I have to round off up to decimal one place. Okay. Then it means what? Which digit I have to remove? I have to remove 8. Arey nalayak, 2.4. How you are saying 2.4? We have to drop 8. We have to drop 8. Now 8 is more than 5. 8 is more than 5. So preceding will increase by 1. Preceding will increase by 1. Then what I can say? 2.5. Preceding is increased by 1, 2.5. This everybody got. So which we have to drop? If it is a greater than 5, less than 5, then easily less than 5, no change. Preceding digit, greater than 5, preceding increase by 1. This is for the greater than 5, less than 5. Now for the 5, if you have to drop the 5, if you want to drop the 5, greater than 5, less than 5, okay. Now you want to drop the 5, like I am giving the example. Suppose this. So which digit you have to drop? It is a 5. Then we will first what we will do, we will check the preceding digit. Check the preceding digit. If it is a even, for greater than 5, less than 5, only one thing we have to do. But for 5, we have to check the preceding digit. If the preceding digit is even, then it will remain unchanged. Directly draw 5. Okay. If the preceding digit is even, then directly draw 5 without changing the preceding one. But if it is a preceding one is the odd number, then we will increase it by 1. So again I am repeating, if the digit which you have to drop, it is a 5, then first we will see the preceding digit. If the preceding digit is even, then it will remain same. Okay, but if it is a odd, then we will increase it by 1. Okay, like here I have to draw 5. Now preceding digit is what? 4. 4 is even. So I said even, then it will remain unchanged. Then what I will get? 2.4. Okay. But suppose here I am saying what is the answer? 2.55. What is the answer? 2.6, because here I have to draw 5. Now preceding I will check. Preceding is the odd number. So it will increase by 1. So answer is 2.6. Completed. Now what I am going to say, that is not given in the NCERT, okay? And for this different rules is there, okay? People are saying different rule, but mathematically what I'm going to write, that is correct, okay? In our module 1 or 2 question also has given, okay? But it is not very important, means don't waste more time for that, because NCERT only up to the 5, greater than 5, less than 5 and equal to 5. This rule has given, okay? So just for like if you are solving any book and there you are getting the problem, so then for that I am saying, okay? Otherwise it is not important. Most of the time what will happen, either you have to drop greater than 5 or one digit you have to drop, either it will be greater than 5, less than 5 or equal to 5, okay? So these 4 you have to know, okay? But suppose you have to drop more than one digit, Like I am giving the example. .452. Okay. You have now here you have to round off up to the decimal one place. You have to round off decimal one place. Okay. Then how many digits you have to drop? You have to drop this. Okay. Everybody getting or not? Then in the childhood, what we were doing sequentially. Like we will start from the last digit, then we will round off, then like this, like this, like this. We were going up to that first digit. Okay. Here sequential, there is a no meaning. What we will do in that case, basically you will see what you have to just after that digit, like you have to write the decimal one place. After that you have to see there is a 5. Okay, means 5, we have the rule greater than 5, less than 5, equal to 5. So 2.4 up to after the 4 we have the 5. So we have to drop what? If you see this, if 2 is not there, then it means you have to drop 5. You have to drop 5. For the 5, we have the rule is what? We will check the preceding one. If it is a even, then it will remain same. If it is a odd, then it will increase by 1. But here you don't have to drop 5. You have to drop more than 5. Why? Because after 5 we have non-zero digit. After 5 we have non-zero digit. So it's like value is what you have to drop, not the 0.05. You have to drop 0.052. This you have to drop. 0.052 you have to drop. So its value is what? More than 5 there. More than 5. So more than 5, only one rule is there. Preceding we will increase by 1. Again I am repeating. Here 2.452. If I have given only 2.45, it means only one digit you have to drop, that is 5. That is 5. Then you will check for the preceding. Preceding is even, then remains same, or then increase by 1. But here I have given the decimal 3 places, and the 2 digit I have to drop, 5 and 2. Okay. So after the 5, if you have to drop the 2 or more than 2 digit, and after the 5 there is any non-zero digit are there, means the value will be more than 5. The value will be more than 5. And when you are to drop the more than 5, then preceding will increase by 1. We are not checking the even or odd. Should I repeat again? So you will not drop sequentially, like first you have to drop, you will drop the 2, 2 is less than 5, so okay, drop directly. Now come to the 5, then I will apply the rule for the even and odd. No, you have to drop 52, basically 0.052. 0.052, it is a more than 5, its value is a more than 5, okay? Then more than 5, then what we will do? We will increase the preceding digit by 1. Are everybody getting or not? Like here I gave 450. Then it means I have to draw 5. I have to draw 5 because after the 5, 0 is only there. Okay, so value is what? 5 basically we have to draw. But after that, suppose anything I am adding here, then it means this value is more than 5 or not. I don't have to draw 5. I have to draw more than 5. If the 5, 0 is there, after that 0 is there, then it means you have to draw 5. But here when I am writing like this 5, 2, it means you have to drop more than 5. More than 5, only one rule is there. Understood or not? Okay, so if you have to drop more than one digit, and then like 5, after that some non-zero digits are there. After that anywhere, non-zero digits are there after 5, it means you are going to drop more than 5, so preceding will increase by 1. Without thinking anything, you have to increase the preceding by 1. So what is the answer? 2.5. Okay. One more. Now you will say the answer. Decimal one place you have to say. Tell fast. Means what you have to drop? You have to drop this. I said you have to drop 5. After that non-zero, any non-zero digit is there, any place, it means this value is more than 5. It means directly you will increase the preceding by 1. So answer is 3.8. Okay, good. Now last example. Tell what is the answer. So what I said, we will not go sequentially. We have to drop what? This whole. Okay. Here 4 is there. After that, any digit you are writing, ultimately this, you will get here 5 when you are adding 0.001. When you will add, then here you will get 5. Then here you will get 5. Before that, 0.049. If I am adding 0.001, then it will become 5 here. Then I will apply the rule of 5 means 5. Then I will see the preceding one. Preceding one is the odd. Then it will increase by 1. But if I am writing 49, if here I am writing the less than 5, so whatever the digit I am writing here, ultimately its value, its place value will be less than 5. Less than 5, then there is only one rule. What? Directly drop the digits. So answer is the what? 4.3. Don't, what I said, first don't like go through like this, 9 you drop, then preceding will increase by 1, so it become 5. Now I have to drop 5, then preceding will be odd, so it will increase by 1. We will not do that. What I said, you have to think all digit together. Now you have to drop 0.049. 0.049 place value is less than 0.05, because you will add the 0.01, then only it will become the 0.05. It means you have to drop less than 5. Less than 5, only one rule is there. Preceding will remain same. What is the answer? Shambhavi, still doubt is there? Shambhavi, doubt is there? So I said what? Unnecessary, don't think more, don't waste more time. But remember that suppose any book you are doing, any other material you are doing anywhere, you got the question like this, then you have to think this concept. Otherwise, in the NCERT also this type of problem is not there. Only 5 you have to drop, less than 5 you have to drop, or greater than 5, less than 5 or 5. Okay. So answer is what here? I have to drop 0.049. So value is what? Less than 5, then we can say directly 4.3. It is enough in the round off. Okay, because round off they are not going to ask the round off question. We have to use in the significant figure or the error. Okay. So no need to waste more time in that. Okay, completed. Now next small concept, order of okay, order of magnitude. Okay, these are the small concept that we have to know, because otherwise small question will ask, and if we don't know then we cannot do, because here we cannot use the mind, means what is the order of magnitude. Okay, so what is the order of magnitude? So one thing, large number or very small number or very large number, we write in the scientific notation like 10 to the power something, this into 10 to the power something. Like so many example we have, Avogadro number 6.023 into 10 to the power 23. So if we are not using this notation, then 6.023 into 10 to the power 23. If you are writing in the standard form, it will be so many zeros you have to put. So to make representation to simple, we are using this notation. Okay, A into 10 to the power B. Okay, very small number like electronic charge, 1.6 into 10 to the power minus 19. So after decimal, you have to put the 19 zeros. So like this quantity what? Very small. So when very small quantity we have or very large quantity we have, then we are using this notation. Okay, so we are representing like A into 10 to the power B. A into 10 to the power B. Okay, but to write in this notation, what we are following here, A must be between 1 to 10. A must be between 1 to 10. It has to be more than 1 and less than 10. Because if it is a more than 10, then what we will do? We will make it less than 10 and 1 power of the 10 we will increase. Like suppose you are getting 11 into 10 to the power 5. So it is a more than 1, then what I can write? 1.1, and here I will write 10 to the power 6. This is the correct notation. Okay. Everybody getting or not? So A, what is the range of A? A has to be between 1 to 10. And B can be positive or negative integer. it will be integer, but it can be negative or positive. A small number it will be negative, large number it can be positive. Okay, so like so many examples are there. Electronic charge 1.6 into 10 to the power minus 19. Okay, so means power is here minus 19 and we are adding 1.6, and you can see 1.6 is the less than 10, more than 1. Electronic mass 9.1 into 10 to the power minus 31. So A value is less than 10 and the power is minus 31. Planck constant 6.6 into 10 to the power minus 34. So A value I can say 6.6 and the power is minus 34. Avogadro number 6.023 into 10 to the power 23. Power is 23 and the A value is 6, that is less than 10. That is the correct notation of the quantity. Everybody got or not? Now in that quantities, what is the order of magnitude? What is the order of magnitude? So for the order of magnitude, if A is less than or equal to 5, okay, if they are asking in any quantity they given in the 10 to the power, in this notation they given, and they are asking what is the order of magnitude. What is the order of magnitude? For that what we will do, if A value is less than or equal to 5, then order of magnitude, what I can say, directly power. Whatever the B value, directly you can take as it is. Okay. In NCERT, they are using the B only both cases. So don't get confused if you are reading the NCERT. I am saying in the different form. Okay. So I write directly 10 to the power what? A into 10 to the power B. I am dealing in that. When the 10 power is B and you check the A and A is less than or equal to 5, then directly whatever the power, it is the order of magnitude. Okay. Second thing, if A greater than 5 means it will not cross the 10. We have to write in the proper notation after that, like A has to be less than 10. A greater than 5, less than 10. Then order of magnitude, what we can say, it will be B plus 1. Means whatever the power you write, in that you will add 1. Okay, then it will be the order of magnitude. Okay, like example, like Planck constant. If I am asking what is the order of magnitude? What is the order of magnitude? Like minus 34, how? Minus 33, minus 33, minus 33. That is a minus 33 is the answer. Why? Here power is what? Minus 34. So B value is what? Minus 34. Now we will check the A value. A value is what? 6.6. 6.6 is more than 5. So order of magnitude is the B plus 1. Now what you will get? Minus 33. So order of magnitude is the minus 33. Like Avogadro number I am saying. What is the order of magnitude? (24). So order of magnitude will be what? Here 23 is the power and the A value is more than 1, then it will be plus 1. Okay. Similarly, like electronic charge, that is 1.6 into 10 to the power minus 19 coulomb. What is the order of magnitude? Minus 19. Why here power is what? Minus 19 and the A value is what? 1.6. That is a less than 5. So order of magnitude is the power. So it is what? Minus 19. So this is a simple small concept. Completed. Okay. Now next is what? significant figure. Maybe in the ABC class you will listen also in the chemistry means I think. So what is a significant figure? What are the rules to determine the significant figure? Maybe you know. Okay. So who will say what is a significant figure? Anybody know? Like if I'm asking what is the definition of significant figure, what do you understand from significant figure? Anybody has an idea? So listen, significant figure, one thing, this whatever the rule we have, it is given in the NCERT or whatever the rule we make, okay, so people are thinking, somebody saying last uncertain digit. Okay, so last uncertain is a significant only. Okay, now listen, what I said, significant figure, this rule has made for the like physical, any physical quantity, any measurement we are measuring. Okay, so this rule has not made for any number. Significant figure, we are not dealing with a number, we are dealing with a physical quantity, or we are dealing with any measurement. Okay, any experimental data, any measurement, okay, or any physical quantity. That rule is not for the number. Okay, one thing. So what is the meaning of significant figure? So significant figure is what? It is in any measurement when we are measuring any quantity. Okay, so in any measurement, total number of the certain digit plus one uncertain digit. Total number of certain plus one uncertain digit, it will be equal to the significant figure. It will be the number of significant figure. Again, I am repeating, what is the meaning of significant figure? In any physical quantity representation or any measurement, total number of certain digit plus one uncertain digit, it is the number of significant figure. It is a number of significant figure. Okay, what I said again, if you want to write, you can write. It is a sum of all certain digit plus one uncertain digit, that will be equal to the significant figure. Okay, what is the meaning of certain? What is the meaning of uncertain? So a small example I am giving. We are using the normal meter scale. Okay, suppose I am making the scale here. Okay, I'm zooming this. Suppose this is the scale, okay, and white, what I made, white is the any thread. Okay, if I am saying what is the white, whatever white line I made, that is a suppose thread, and you are measuring by the scale, normal meter scale. Each division is the 0.1 centimeter. It is each division is a centimeter. Like here, this is what big division, like here 1 centimeter, 2 centimeter. This is each small division is a 1 millimeter. Okay, so these are the centimeters, and here one division is the 1 millimeter. So who will say what is the length of this string what I made, or thread? According to the scale, what is the length of the thread? Whatever you are observing on the board, what is the length of the thread? 2.2 or 2.3. You will say the two data. 2.2, 2.3, 2.3. Okay, so means any other answer? Okay. Kiramai becomes the vernier calipers. Means I gave you the scale and you become the vernier calipers. You are measuring up to the decimal two place. How you can write the 2.25? Now listen. One thing first I will explain the Kiramai answer. What she has written, 2.25 centimeter. Means by representing the data, we cannot be the more intelligent. Means you thought, okay, it is crossing the 2 and it is not reaching the 3, then I am writing the 2.25. If you are for this measurement, first thing I am explaining why we should not write like this 2.25, 2.26. Because if you are writing the 2.25, it means what? When you will send this data, suppose you are measuring some length and you are sending the data to somewhere. So when you are sending the 2.25 centimeter length, so suppose you send this data to me, then I will think that this length you measure by using vernier calipers. Why? Because vernier calipers can measure the decimal 2 place of the centimeter. So suppose error and something required, so I will consider the least count error 0.01 centimeter. So if you are writing that data up to the decimal 2 place, so it will confuse me. Means you have used the vernier calipers to measure this length. But basically what you have used? You have used the normal meter scale. Normal meter scale, what is the least count? 1 millimeter or 0.1 centimeter. So for this scale, we cannot write for the decimal 2 places. Everybody getting or not? So this data, if you are writing like the decimal 2 places, then it is a wrong. Okay. So this cannot be the answer. Okay. Now, somebody is writing the 2.2, somebody is writing that 2.3. Okay. It means only the problem is what? And nobody is saying. Anybody is saying 4 point something. Okay, nobody is saying. So here 1, here 2. Okay, everybody is sure about that 2 point. Only the problem is what? Somebody is thinking measurement cross the 2.2. That's why they are taking as a 2.3, because it is a crossing the 2.2. Somebody is thinking it has not reached to the 3, 2.3. That's why they are saying 2.2. So two answer is what? 2.2, 2.3. Somebody is thinking it is crossing the 2.2. That's why they are saying the 2.3. Somebody is thinking it has not reached to the 2.3. That's why they are saying 2.2. Okay, but everybody is saying 2 point. So this 2 is certain. Everybody is saying 2 point. Somebody is writing 2.2, somebody is writing 2.3. That decimal first place is uncertain. Okay. Only problem is what? Somebody is saying here 2.2, somebody is saying 2.3. It means, suppose I am writing the data 2.2 or 2.3. Then in that data, how many certain, how many uncertain are there? So left of the decimal, this 2 is what? Certain, this 2 is what? Certain, and this is what? Uncertain. But here, because here is the problem, it may be the 2.2 or maybe 2.3, slightly more than 2.2 and less than 2.3. So this is uncertain, this is certain. So how many significant figure is in this data? Number of the certain plus 1 uncertain. Okay, so then significant figure we can say 2. This data has the 2 significant figure. So rule we have made according to that. Later you will learn the rule, and from the rule we can decide how many significant figure are there. But this definition also you have to know. Later in the error I will discuss some question. When you are going through the error concept and this, then you will get the answers. Okay. But by using the definition of significant figure, then answer will change. Okay. So again I am saying, in our data, if any data we are representing, so in that how many uncertain digits has to be there? Only 1. Rest of the digit has to be certain. So uncertainty we cannot write more than 1. This everybody got or not? So means all other certain, any number can be there, but uncertain, how many we can write? 1. Everybody got or not? So in any measurement, certain can be any number, but the uncertainty must be 1 only. Understood or not? So that's why I said that definition, total number of the all certain digit plus 1 uncertain digit is the significant figure. Okay. Okay then. Now rules to determine significant figure. One rule is what? All non-zero digits are significant. All non-zero Like suppose I gave the example, I'm writing 2, 3, 4, 2. So 2, 3, 4, 2, how many significant figure? All non-zero digits, without thinking anything, how many certain, how many uncertain, directly by the rule, we can say, how many significant figure? 4. 5? How 5 na like? Blood vision in the morning. Okay. Second, all zeros between two non-zero digit are significant. So what I am saying here, all zeros between two non-zero digits are significant. Means suppose I am writing how many significant figures are there? How many significant figures are here? Seven. Okay, so means all zeros, this zero is coming between 3 and 4. These two zeros are coming between 4 and 2. So all the zeros which is coming between the two non-zero digits, they are significant. So what is a significant figure? I can say 7. This okay? Next one is what if measurement is less than 1, then all zeros just right of decimal are insignificant. So measurement is less than 1. Measurement is less than 1 means how you will write. Suppose like this. Okay. So if it is a 1 or more, if it is a more than 1, then you can write here 1 point something, 2 point something, 3 point something. But when it is a less than 1, then how you will write? 0 point something like this. Okay. So what I said, if the measurement is less than 1, we will write like this. Okay. Now, if there is a zero just right of the decimal, then those zeros will be insignificant. So like here, right of the decimal, we have the 2 zeros and they are the insignificant. So these digit only we will take as a significant. So how many significant figures are there? 2. So if the measurement is less than 1 means here, suppose I am writing 2. Here I am writing 2. Then how many significant figures are there? Then we will go to the rule number 2. All the zeros between non-zero digits are significant. Then I can say 5 significant figures are there. But if this is there, so how many significant figure? 2. So significant figure, what I can say? 2. That example also you can write like 2.0023. Suppose same, but I give here 2. Now it is a more than 1. It is a more than 1. Then, and we can say here, these zeros are coming between two non-zero digits. Then significant figure I can say 5. Okay. So if measurement or that quantity does not contain decimal, then trailing zeros are insignificant. So if the number does not contain decimal, then trailing zeros, what are the trailing zeros? So like suppose I am writing the example 3400. Okay, so this number does not contain decimal. This number does not contain decimal. Then rightmost zero. Rightmost zero means after that no any non-zero digits are there. Because if there is any non-zero digit in this side, then what will happen? Then rule number 2, then they will be significant. Okay. So what are the trailing zeros? Rightmost zero. Rightmost zeros. After that, no any non-zero digits are there. So they are called trailing zeros. All rightmost zeros. After that, no any non-zero digits are there. So they are trailing zeros. So these zeros are the, we can say what? Trailing zeros. Okay, so number does not contain decimals, so trailing zeros are insignificant. So this is the insignificant. So what is the number of significant figure I can say? Significant figure is equal to 2. But in different books maybe, or maybe different institute, or maybe some lecture you have seen, maybe some teacher said, if suppose I am writing like this, 3400 centimeter, how many significant figures are here? If I am writing 3400 centimeter, then how many significant figures are there? I want your answer. That what you have learned, what your teacher said, like 2400 centimeter if I am writing, so how many significant figures are there? One, two, four, 2, 4, 2. Now I will say why you are somebody saying 4, why somebody is saying 2. Okay, so maybe it has said when unit has given, then all trailing zeros we have to take significant. When unit has given, all trailing we have to take as a significant. But when unit not given, then we will take as insignificant. Maybe this rule said to you in the school or somewhere, means unit is not there, then trailing zeros we will take insignificant. Okay, if unit is there, all trailing zeros we will take significant. Yes or no? Maybe this has said. But what I said in the beginning, this significant figure rule is not made for the number. For the number, this rule not made. This rule is made for the measurement or any physical quantity. When I am saying any measurement or the physical quantity, so measurement will definitely have the unit. In the example, I am not writing the unit, but it is a measurement. It is a measurement or physical quantity. So they will have the unit. So rule has made for the significant figure. Then why this rule has made means if the unit is there, then all trailing zeros will be significant. If the unit is not there, then all trailing will be insignificant. Okay. So one thing, this rule is not there like unit and no unit is there. Because we are dealing with the measurement or the physical quantity. So unit means we have to assume the unit is there. 3400, any unit, it is any measurement. Okay, one thing. Second thing, what later you will learn in the NCERT also some example has given. If you are saying, sir, it is not, no unit is there, it is a pure number. 3400 is a pure number. No unit has given, it is a pure number. Then pure number means no any measurement. It is not a measurement. It is not a measurement. It is a number, pure number. Then it can have the infinite significant figure. In the NCERT other page they have explained like 2, like diameter is a 2r. So 2 can have the infinite significant figure. So if it is not a measurement, it can have infinite significant figure. Okay, so means what I said, this rule has made only for the physical quantity or the measurement. So this like unit has given, unit not given, then significant figure will change. No, 3400 centimeter when we are writing without unit also, if I am asking like if it is a measurement, so then what is a unit also I have written, then we will say the number of significant figure is what? 2. So 3400 centimeter, what is a significant figure? You will write 2. Everybody got or not? Completed? So we can apply this unit rule, means what? Shambhavi, we can apply this unit rule means what? Means what I said, whether unit is there or not, unit is there, then also trailing zeros will be insignificant. Shambhavi, what I said, even units are there, then also the trailing zeros will be insignificant if it does not contain decimal. If it does not contain decimal. Number, if the measurement does not contain decimal, then all trailing zeros will be insignificant. If it is having the unit, then also, okay. If measurement contain decimal, then all if the measurement contain decimal, okay, then the trailing zeros will be significant. Then trailing zeros will be significant. In our childhood, what we were doing, suppose I'm giving one addition. Like this addition I'm giving. So in the addition, what we were doing, decimal addition in the class 3rd, 4th, we were adding any number of zeros. Okay, after that we were adding 2, 4, 5, dot, 3. Okay. We were doing or not. So means any number of zero required after decimal we were putting. Okay, according to the requirement we were putting. There is a no change when we were adding any number of zeros. So now what I am saying, if the measurement contain decimal, like suppose I am saying, then all trailing zero become significant. All trailing zeros become significant. Okay. Who is saying the addition 3.5 na like? 3.200 if I am writing. So what I said, if the number contain decimal, then all trailing zeros will be significant. Then how many significant figures are there? All trailing zeros are significant. So a significant figure I can say what? 4. What I said, in childhood any number of zeros we were adding without caring, after the decimal without caring. But now here this zero has a significant. By this rule, earlier what we were doing, we were adding any number of zeros after the decimal, no effect was there. Okay, those zeros are useless basically we can say. But here what I am saying, if the number contain decimal, these zeros are the significant. Why this we have learned they are different, here why different? So what I said, this significant figure, we are dealing with the experimental data. Okay, if I am sending you the length 3.200 centimeter, if I am sending this measurement to you 3.200, by this data you will get to know that you will find, means this length I measure by using screw gauge. This length I measure by using screw gauge. If suppose I am sending 3.2 centimeter, I am sending 3.2 centimeter, means by this data you will get to know 3.2 centimeter. Okay, I have used the normal meter scale whose least count is the 1 millimeter or 0.1 centimeter. Then you will recognize, okay, I use the device normal meter scale. Suppose the same data I am sending like this, 3.20 centimeter, value same, but I am sending 3.20 centimeter. It means this data, this measurement I have find by using the vernier calipers, because vernier calipers can measure the decimal 2 place. Okay, so this zero has a meaning. By this zero, by this precision, I am saying that which instrument I have used. Okay, what is the least count of the instrument I use? I will not put randomly, means I am using the normal meter scale and I will write like this. It means I am writing wrong. Okay, because normal meter scale can measure the decimal 1 place, how I am writing the 2 more places. Okay, so that's why these zero are the significant. So if I am writing like 3.200 centimeter, it means I use the screw gauge to measure this length. That's why I am writing the decimal 3 places. Everybody got? That's why these zeros are significant. These zeros are significant. Are everybody getting or not? Okay, so that's why this rule has made, means if the number contain decimal, then all trailing zeros will be significant. Like in the 1 year in the NEET, they asked this question. Like any wire diameter is measured by using the diameter of the wire is measured by using the screw gauge. Then reading of the diameter can be like this. They given. A diameter of the wire is measured by using the screw gauge. Then what can be the diameter of the wire? Basically all the values are same, but what we will write? We will write third one. Why? Because the screw gauge can measure the decimal 3 places, okay, of the centimeter. Then we will go to the third option. Everybody got or not? That's why this 0 has the meaning, okay. Okay, last rule. In changing unit, number of significant figure remain same. Means in changing the unit, significant figure should not change. Means maybe the whatever the relation we have, meter, kilometer, centimeter, that we have to follow, but the number of significant figures should not change, okay. Like one example I am giving. Suppose I am saying 6.20 meter. How many significant figure are there? 3. 6.20 meter. How many significant figure? 3. Okay. I want to convert into the millimeter. First listen, then you can write. If I want to convert in millimeter. Meter and millimeter, what is the relation? 1 meter is equal to 1000 millimeter. 1 meter is equal to 1000 millimeter. Okay. So I will multiply this by 1000, then I will get 6200 millimeter. 6200 millimeter. Okay. But if I am writing 6200 millimeter, then how many significant figure it has? 6200 millimeter. How many significant figures are there? 6.20 meter. I am converting in 6200 millimeter. I am using the meter and millimeter relation. Again, like 4, you are saying. Whether unit is written or not, trailing zeros are insignificant if they are not containing decimal. Ramya, Ashok, 2. Okay, so left hand side we have 3 and right hand side we have 2 only. 6200 millimeter has how many significant figure? 2. But what I said, by in changing the unit, significant figure should not change. It has to remain same. But I cannot change the relation between the meter and millimeter also, because we know that 1 meter is equal to 1000 millimeter. Then what we will do? In that, we will not write this notation. Okay, we are using the scientific notation. How? 6.20 into 10 to the power 3 millimeter. Okay, now you can see relation, say, right, because 1 meter is equal to 1000 millimeter, that I follow. And how many significant figure in the left hand side? 3. And how many significant figure in the right hand side? 3. So for remove that ambiguity, because 6200 millimeter if I am writing, so it has the 2 significant figure, but changing unit should not change the significant figure. So that's why I cannot go to the 6200 millimeter. But if I want to follow the correct significant figure, so I can use the scientific notation. Now in this, how many significant? 3. In this, how many significant figure? 3. And it is following the right relation. 1 meter is equal to 1000 millimeter. Okay. So these are the rule. Now in the mathematical operation, how to find the significant figure and all. Next class I will discuss. Okay. Okay then. Bye bye. Because next class will be there after 5-10 minutes.